We'll talk pyramid and cone. Pyramid and cone today. Again, you tell me, what's the volume of a pyramid? You know where to look now, right? Everything's on the formula sheet. So volume of a pyramid. Volume of a pyramid. What do you got for me? Anna, volume of a pyramid? Ooh, yeah, 1/3. And then our formula from yesterday for a prism, 1/3 BH. If you don't want to write it down, you don't have to, but I want to make sure we are clear. B, area of the base. And I'm going to make an even bigger point here for H. Because you guys remember, I think it was a week ago today, I get up on the desk and make a big fool of myself with the Mission Impossible stuff. You remember, a pyramid has a altitude, which is a height, Mission Impossible height, and it has a slant height. This H is your altitude. All right? Altitude of the pyramid. Not the slant height. All right? If you want to write Mission Impossible height in, it helps you remember better, write it in. All right, but it's the altitude, the one that comes from the apex straight down. All right, that's what we're talking about for H. All right, what do you say? Let's look at the volume of this pyramid right here. One-third, make sure that 1/3's in there. And darn it, it's on the formula sheet. Just copy it. I'll go off to the side here, and not that I really need to, but how are you going to find the area of the base here? 10, how do I find that area of the base? What is it? Which will be what here, Iris? 10 and 10, yep. It's square base, 10 times 10. So B is 100. Come back here. 1/3 times 100. All right, what's the 13 pointing to here? Let's use some vocab. What's the 13 pointing to? 12, what's it pointing to? The 13 inches. Yeah, not the H I want to plug in because that's the altitude. I don't want to plug in the slant. I need the altitude. Remember how we find it? We make a right triangle out of this. So here's my H right here. And then anybody, let's remember, how do I find that other leg? What's always the rule? How do you find the other leg? 4. It's all right. That's how I'm going to find it, but I need that other leg here. Remember how to find it real quick? Yep. So we got 5 here. So I'm going to go H squared or A squared plus 5 squared equals 13 squared. And then you guys can help me find H. All right, what do you got for H here? 9 when you're ready. 12, good work. So there's 12 right there. And we should be good to go now. $400. And remember, if we're doing volume and you're putting units, make sure they're cubed. All right, we're good. Anything? All right, these questions usually trick you guys up when I put them on out of the textbook. I got a square base for a regular pyramid. The perimeter of that base is 36. Height is 15. What's the volume? Excuse me. All right, so we already know the height is 15. And now people are going to say, this question always comes up all the time. Hey, Mr. Carlino, that 15, is that talking about the actual height, altitude, or the slant height? If I want slant height, I'll write the word slant in there. Okay? If it just says height, that's the one we want. If it says slant height, I'll write the darn word slant in there. All right, let's go capital B because it's not 36. Let's get a little visual of this. It's a square. That's not a great visual. Here we go. Square base. perimeter is 36. Perimeter is 36. So can you get me the side lengths then for me so I can find capital B? The perimeter is 36. All sides are equal. What's each side? 3, Spence? I don't know why I just stalled there. But yes, it is 9. Yep. So go down. What's the area now? 13?
Or wait, no.
Area of the base, the square base. It's all right.
81.
81. Yep. 9 times 9. So 81 times a third times 15. All right. We having fun here before we go to Egypt? All right, Great Pyramid of Giza. I'm going with Giza. That's my final ruling. If you want to go Giza, go ahead. I'm going Giza. If you guys that weren't here earlier, you just want to take in. There you go. The Great Pyramid of Giza right there. It's an actual thing. Anybody ever been to Egypt? Okay. I don't have a follow-up. Guess we're just going to have to find it now. All right. Wow. How about that volume, kids, huh? Almost 2.6 million cubic meters. So basically, not that you care, but I do. I don't have one in class, but you've seen a meter stick before, maybe? It's pretty big, right? Pretty decent size. Imagine a cube that's 1 meter by 1 meter by 1 meter. It's a pretty big cube, right? Because if you take that meter stick, just even hold it up, that's got a pretty big cube. There's 2.6 million of those in Pyramid of Giza. All right, there's 2.6 million of those. Yeah, I know. Everyone's impressed. We good? Okay. All right. What are we looking for? Find the length of one of the sides of the base. Here we go. It's going to be a good one. Well, it's a pyramid, and I know the volume. So 1/3 BH. I just don't want to fly through this. Volume, I'll plug that 2 million in over there. 2,592,276 equal 1/3. And we're looking for a side of the base. Hey, I can't find a side of the base unless I know the actual base. So I'm going to keep that big B. I can't find a side unless I actually know what the area is. And the height is 146.5. All right, can you guys help me out finding big B now? And when you find capital B, that's going to be the area of the base. So get B by itself right now. You can move the 1/3 over. You can move 146.5 over. You can multiply the two together, then move it over. It doesn't matter to me. This isn't my answer either, so make sure we don't round, right? Don't round it when you find capital B. Make sure we match here. I'm getting about 53,084 for the area of the base. So can we get this, first of all, before I move on? Can we get this? Or is this a no? You can multiply both sides by 3, then divide by 146.5. You can do the reverse, or like I said, multiply these two and then divide both sides by it. Okay, that's the area of the base. Let's think about this. That's the area of the base, but I only want one side of the square. So that's my area right here. And I only want one side of the square though. So what am I going to have to do to that number to get to the side of the square? Don't divide it by 4. That's not that. That would be if I had the perimeter. Okay, if I had the perimeter, I'd divide by 4, but I don't here. I have the area. I have the area. So how can you go from here to the side? Nate Dog, let's roll. Take the square root, right? Because I would do side times side. So if I want to go backwards, I'm going to take the square root. Good deal. So take the area and take the square root. You'll get a side. Round it to the nearest meter. You right there, boss?
Yeah, I thought it was 130.
Yep. I'm telling you, it drives. You know why it drives me nuts? Because where's that formula? Yeah. So no reason why we should ever get any of these formulas wrong. Everyone always forgets the 1/3, and I start flipping desks. $230 look good? 230 meters. Wow. That's one big base. 230 of those meter sticks. That's just one side. Okay, we're good? All right. So there's a pyramid. Let's go cone now. Cone. You let me know what's the volume of a cone. 3, Spence, you're up. Volume of a cone.
1/3 pi r squared.
Yeah. It's 1/3 BH. But why is there pi r squared? Because the base is a circle. Still 1/3 BH. And then do you guys have A and B there? Yep. Okay, so let's just go through a basic one before we get into some more word problems. Leave your answer in terms of pi, and then we'll round our answer to the nearest 10. All right, so part A, 1/3 pi r squared times the height. Everyone see the problem? No radius. All right, no radius. Using those numbers, though, how can I find what the radius is? 13. Charlie, how can I find what it is? Pythag, you got it. So it looks like I'm going to go 15 squared plus b squared equals 17, the hypotenuse. All right, what's your radius length when you get it? Oh, 13, Charlie. Let's go. 8. And okay, out of 17 and 15, what are you going to plug into the formula? Which is the height we're looking for? Because those are both heights. 4, what height which one we want? 15, the altitude. Good. And remember, when we leave our answer in terms of pi stays in our answer. So right now in your calculator, I'm doing 1/3 times 8 squared times 15. I'm getting 320 pi. Go back to your calculator. Let's do part B real quick. Go back to your calculator. Now take that answer, find out what 320 pi is, and round it to the nearest 10 for me. All right, we're good. I don't need one in here. All right, it's bad enough I got one out on the track now. $1,005.3. We're good. I just want to make sure because these problems get more difficult as we move on. All right, the volume of a cone is 96 pi, height's 8. What's the diameter? One-third pi r squared times the height. Now, I know you guys know this, but just to make sure, we're trying to find the diameter. There's no diameter in my formula, but there is a radius, which we can double at the end, right? All right, so 96 pi over here for the volume. One-third pi, looks like we're solving for radius squared, and the height is 8. All right, I really just assigned this problem because I want to make sure you can solve it algebraically. I'm pretty confident you guys could substitute in all those numbers. What's on both sides? Pi's, right? They're gone. If I don't have pi's on both sides, I can cancel them out, but I do. And then I'm really interested in what you guys are going to do next. So 96 equals 1/3 r squared 8. All right, what's your next move? Because there's a bunch of moves here you can make. Your call. 2, next. 12, your call.
Multiply each side by 3.
I'm fine with that. Let's get rid of the 1/3. Multiply both sides by 3. R squared times 8 equals, oh boy, 8. Let's see, that's 8. If I carry the 1, 288. Calculator. Human calculator. Next. 5.
Divide by 8.
Good job. Okay, what's that going to be here? That goes in 3 times with 4 remaining. 8 and the 48, 6. All right, so R equals 6, and you guys got the diameter. 12. Whew. How about this one's always a classic. All right, I got a cone and I got a cylinder. I want to fill that cone with as many cups of water as I can to fill the cylinder so it won't overflow. How many cups am I going to need? So it won't overflow. First, how do I know this is volume other than it's a volume day? I'm filling inside, right? I'm filling the inside of it with water, so I know it's a volume. So we're going to have to compare the two volumes and do something with them. So again, everyone understand, I'm going to fill the cone up with water, dump it in the cylinder. How many cones is it going to take to fill it up without overflowing? All good? All right, so go ahead right now. We'll do the cone first, and then we'll do the cylinder from yesterday. Three squared. Everyone all right? I'm not plugging in 5. You find it out. Do Pythagorean theorem if you don't know that number. Then I'm going to plug in for the height because it's not 5. That's the slant height. This is a Regents type problem here. What are you guys finding for the height of that cone? 5, height of the cone? 4, good. Doing Pythag. And a reminder, this is not our final answer. So as you guys are typing this in your calculator, when you hit that equal sign, we'll write it all out. So the 37.699. All right, cone from yesterday. Look on the darn formula sheet. It's not something you got to struggle with memorizing. Pi r squared times the height. All values are already there for the cylinder. 4 squared times 7. 7? Yeah, it's 7. Okay. You guys have 7 too, right? Okay, well, I don't know why I have 6 in my old one. Okay, how are we going to figure out how many cups? So again, I pour a cone in. There's about 37.7. Boom, pour it in. I pour another one in, another 37.7, but this is how much space I have in the cylinder. All right, what do you got for me?
I divided it. and then-
There you go. Yep. So I'll go, whoa, relax. So number of cups. I'm going to take 37.7699. I'm sorry. Sorry. Take the volume of the cylinder, divide by the cone, and let's do that up here. $351.858.3772 divided by 37.6. So how many cups? Full cups, because read the directions. Determine and state the number of full cups water needed without overflowing. So do I go 9 or do I go 10 here? Because that's how many cups it's going to take. But as we know, we can't do a third of a cup there. So 9 or 10. That's what I was thinking.
9.
Why 9? Because if I do 10, what's going to happen? It's going to overflow, right? Because this is exactly how many cups, but we can't do a third of a cup. It's got to be full cup. So if we do 10, that bad boy's overflowing. So it's got to be 9 full cups. Okay. All right. I'm going to leave you to this last one. All right, let's go. Hurry up. Jeez. Of course, the last one. Don't let this crew just decide it. I opened my mouth yesterday and said it's been a while.
Star.
Q. Swing.
At least 3 more I can think of, but it's not my deal. We're good? Okay, let's do it. All right, I'm just going to let you go on your own here. Okay, take your hands off. You got a triangular prism on top and a rectangular on the bottom. I want to know how many total BTUs it's going to take to cool this whole room. Take your time, please. Take your time. If you get stuck somewhere, let me know. I'll put my work up here, but it doesn't mean much. No, wrong. You think you got this correct, stud, huh?
I do.
All right, we'll see. No, nope. It's not 2, it's 2.5. How's that look? Remember that 4,000? Through the windows. I'll leave this up here. Take a look. I can come over and help you too.